we take a quick look at some of the strongest and lightest materials ever made. At number 5, a gyroid-shaped material. This weird-looking pink block may not seem much, but it's actually one of the strongest and lightest plastics ever made. It originates from a 3D design model, which has high surface area in relation to its volume proportion. So it's not really much about the material itself, but it's more about its geometric shape. Ultimately, the experiments revealed that these thinner walled structures actually have more deformation strength than the thicker walled materials. So this is not just limited to plastics, and gyroid structures can be incorporated in many different types of materials, which can therefore have a greater structural integrity. At number 4, metal microlattice. This is yet another material which gets its strength from its structural design. It's made out of interconnected metal tubes which have a crisscross pattern. It's kind of like your bone structure, where it's rigid on the outside, but it has an open cellular structure on the inside which keeps it light. So basically 99% of this structure is occupied by air, so it can bend and twist without losing its form. Now, it's not going to replace aluminum steel because it just doesn't have that compressive strength, but it can be used for interior cabin structures, and this would ultimately decrease the weight of aircraft and ground vehicles. At number 3, aerographite. Composed of carbon tubes, this material is electrically conductive, but it is also very strong. It can be compressed to about 1/30th of its size, and still retain its original shape. But on the flip side, it can actually handle 40,000 times its own weight. Aerographite is produced by a chemical vapor deposition, using a zinc oxide template. Hydrocarbons are injected at a high temperature, and a layer of carbon is left over on the plate. This material also has a lot of potential because it could be used in batteries and capacitors, therefore making them lighter. But it is not the lightest material in the world, and that brings us to the next position. So now we get to the interesting stuff and look at number 2, graphene aerogel. Now, we have seen materials which utilize structure in composites, but what really is the lightest material out there? Well, if you're thinking of aerogel, then you're on the right path. Graphene aerogel weighs 0.16 milligrams per cubic centimeter. That equates to 160 grams per cubic meter. You could literally pick up a huge block of this stuff, and you wouldn't even feel it because it would weigh 0.3 pounds. The graphene aerogel is produced by pouring a solution of graphene and carbon nanotubes into a mold and then freeze drying it. So this process is scalable, and you could do very large forms of this type of stuff. Another neat feature of graphene aerogel is that it can soak up to 900 times of its weight in oil. So it could be used in chemical spills, but having said that, this stuff is really hard to get a hold of, so I wouldn't be holding my breath for that one. At the great number 1, carbine. One of the lightest and strongest materials was created in a lab several years ago. Carbine has about twice the tensile strength of carbon nanotubes, which is a material that has seen very little practicality to the real world. Anyways, carbine is basically a long one-dimensional chain of carbon atoms, linked to each other. But this very thin material is highly reactive, so it's made between 2 layers of graphene, and only a few thousand atoms can be strung together, so we have a long ways to go before we can actually build anything useful with this stuff. But it's still neat to see structures which are built at the atomic scale, and I do think that we will master this holy grail of engineering in the future sometime. So once again, thanks for watching, please like the video if you enjoyed it, and make sure to subscribe to my channel.